Hello, students. Welcome to the 19th session of Quantitative Decision Tools. In this session, we shall understand the calculation of standard deviation, especially under ungrouped data or individual observations. The structure of the session is starting from learning objectives, session outcomes, calculation of standard deviation, summary, and references. The objective of this session is to understand the calculation of standard deviation, particularly in case of ungrouped data. The outcome will be the student shall be able to understand the calculation of standard deviation. So here, when it comes to standard deviation calculation, they are under various types of data, starting from ungrouped data or individual observations, followed by group data non-continuous, that is discrete series, group data continuous. So in this session we shall understand only under ungrouped data. In further sessions we'll understand how standard deviation is calculated under discrete series and group data continuous. So under ungrouped data, we use two methods. There are two methods for calculating standard deviation in individual observations. One is deviation taken from actual mean, and second one is deviation taken from assumed mean. So now we shall understand how standard deviation is calculated by taking deviations from actual mean. So this is the illustration 1. Calculate standard deviation for the following data. So under X, it is 14, 22, 9, 15, 20, 17, 12, and 11. So in the solution, first I have under X column, I'll take down all the individual observations. Next, I calculate D. D is equal to X minus X bar, that is X minus mean. So first I need to calculate mean to calculate D. So mean, as you all know, it is sigma x by n. Sigma x is equal to 120 divided by n refers to the number of observation, that is 8. So mean I get 15. So when now coming back to the calculation of D, here x minus x bar should be substituted as 15. So in first case it is 14 minus 15, I get minus 1. Next it is 22 minus 15, I get 7. 9 minus 15, I get minus 6. Similarly, I'll calculate D for all the observations. Next, I need to square these deviations, that is, I need to calculate D square to remove the negativity. Minus 1 square is 1, 7 square is 49. Similarly, I calculate D square and take the summation. Now I'll apply the standard deviation formula. Standard deviation is represented by the formula, the symbol sigma. Sigma is equal to root of sigma d square divided by n. So root of sigma d square is 140 divided by n is 8. 140 by 8, I get root of 17.5 as standard deviation. Coming to the second method, that is deviation taken from assumed mean. Here I don't go for the calculation of actual mean. Instead, I assume any one of the observation as mean. So here out of x, any one is assumed as mean. In this case, 20 is taken as assumed mean. Keeping that assumed mean, I calculate D. D refers to x minus e. 14 minus 20, I get minus 6. 22 minus 20, I get 2. Likewise, I calculate the deviations. Next, I square up these deviations, then take the summation, and then apply the formula. Standard deviation is equal to square root of sigma d square by n minus sigma d by n whole square. So sigma d square, it is 340 divided by n refers to the number of observation, that is 8, minus sigma d is minus 40 divided by n, that is 8 whole square. So if I simplify, I'll get standard deviation of as root 17.5, which is nothing but 4.18. So without deviations also you can calculate standard deviations. In that, the following step is used. So all the observations are squared and taken x square, and apply the formula. Standard deviation is equal to root of Sigma x square by n minus sigma x by n whole square. Sigma x square is 1940 divided by 8 minus sigma x is 120 divided by 8 whole square. If I simplify here also I get the same, that is root of 17.5, which is 4.18. So if I like to summarize, standard deviation is the most important measure of dispersion in ungrouped data. Standard deviation can be calculated under deviations taken from actual mean, deviation taken from assumed mean, and also without taking any deviations. These are the references that are made. Thank you.